Welcome to the Deep Dive. Today, we're taking a look at something huge, one of humanity's most persistent, really perplexing challenges. I mean, just think about it for a second. Lately, our scientific achievements, they've been incredible, mind-boggling, really. We've cloned animals, we can edit genes now, we've sequenced the entire human genome, heck, we've sent probes to Mars. And yet, there's this one enormous hurdle that just keeps testing us, finding a definitive cure for cancer.
It really is an incredible paradox, isn't it? Decades and decades of research, billions poured into it, brilliant scientists dedicating their entire lives, and still no single, magic bullet that works for every single case.
Absolutely. So today, our mission here, for you listening, is to explore those big, sometimes really frustrating questions like, why haven't we cured cancer yet? And maybe even more fundamentally, does the whole idea of a cure for cancer even make sense? We want to untangle some of the surprising complexities, bust a few myths along the way, and also really shine a light on the remarkable progress that is actually happening right now. Our goal is for you to come away from this with a really clear, concise understanding, feeling, properly informed and maybe even empowered with some knowledge you can actually use. Okay, so let's start with the basics then, because I think the first, maybe the biggest misconception most people have is that cancer is just, well, one thing. Like you'd say the flu or the measles, but that's not really accurate, is it?
No, not at all. And that's such a crucial starting point. Cancer is actually this huge umbrella term. It covers something like over 200 distinct diseases.
Wow, 200.
Yeah. Think of it like a really big family with lots of different branches. You've got lung cancer, breast cancer, colon cancer, stomach cancer, and they all differ quite a bit based on, the tissue where they first started growing.
Mhm.
And what's really key and often missed is that they don't just have different names. They don't behave the same way. They don't grow the same. They don't spread the same. And crucially, they don't respond to treatments in the same way either. And just to add another layer, even within the same type of cancer, say two people with lung cancer, their individual cases can be completely unique.
Okay, 200 different diseases. So the first big takeaway really isn't just a number. It's that fighting cancer often means fighting hundreds of different battles, right? Each needing its own plan. Yet, if they're all so different, what do they actually have in common? What puts them all under that one cancer label?
Right, so what connects them all? Well, the fundamental thing they share is actually pretty simple on the surface. All cancers start with just one single cell that begins to divide uncontrollably, out of control. Normally, our bodies are incredibly well regulated. Billions of cells are dividing all the time, for repair, for renewal. But it's a tightly controlled process. Cells talk to each other, they know exactly when to divide, and importantly, when to stop. This control is absolutely vital because you don't want cells just piling up in the wrong place or dividing when they shouldn't. That leads to problems, big problems.
And I'm guessing the cell's instruction manual, our DNA,
Yeah.
that plays a massive role here.
Absolutely critical. Every single time a cell divides, it has to copy its entire DNA. Billions of letters of code. Any mistake in that copying process, what we call a mutation, can potentially lead to disaster. If the cell's instructions get scrambled, it might start doing things that harm the cells around it. But our bodies have these amazing built-in safety nets. There are supervisory proteins checking for errors, mechanisms to actually repair damaged DNA, and even a kind of self-destruct button. It's called apoptosis, programmed cell death. It's designed to get rid of defective cells before they cause trouble.
So for cancer to even get started, it sounds like several of those safety systems have to fail. It's not just one little slip up.
Exactly. That's precisely it. Cancer begins when those safety systems break down, specifically when mutations hit the genes that control cell division. That's the point where a cell can lose control and just start multiplying. Multiplying. Now, these mutations can happen just by random chance. Actually, the longer we live, the more our cells divide, the higher the probability of an error slipping through the net, which is, a big reason why cancer is more common in older people.
Makes sense.
But external factors play a role too, of course. Things like tobacco smoke, UV radiation from the sun, certain viruses. And yes, some people, unfortunately, inherit mutations from their parents that give them a significantly higher risk right from the start.
Okay, so we've got these internal defenses. But what about our sort of body-wide security force? Is the immune system the last line of defense here?
Yes, the immune system is definitely the body's final vigilant guard, you could say. Immune cells are constantly patrolling. It's a process called immunosurveillance. They're designed to detect and destroy cancerous cells, ideally before they can even form a noticeable tumor. It's an incredibly sophisticated system, and honestly, it probably saves us way more often than we even realize. The problem, of course, is when it doesn't succeed, and that's when the real battle begins.
Okay, let's unpack that then. If the immune system is so good, this cellular police force, why do some cancers manage to slip through? What makes them so tough to beat?
Yeah, this is where it gets really fascinating and kind of scary, actually. Cancer cells aren't just dividing fast. They're experts at survival, masters of adaptation. As a cancer cell divides, it keeps accumulating more and more mutations. These changes transform it into something incredibly resilient, almost, practically indestructible sometimes. It develops multiple defense mechanisms. We can almost think of them as gaining these sort of terrifying superpowers.
Superpowers. Okay, that paints a picture, like a comic book villain. What kind of superpowers are we talking about?
Well, one key superpower is evading apoptosis, that self-destruct button we mentioned.
Right.
Normal cells, if their DNA gets too damaged, they trigger that button and die. It's a safety feature. But many cancer cells find ways to switch off that mechanism. They can be internally broken, full of errors, but they just keep living, keep dividing. And that forces us into using really aggressive treatments, chemo, radiation, that unfortunately damage healthy cells too, because the cancer cells just refuse to die quietly. Another superpower is becoming invisible to the immune system. Remember the cellular police?
Yeah, the immunosurveillance.
Exactly. They're constantly looking for threats, for cells that look wrong or don't belong. But many cancer cells develop mutations that effectively create an invisibility cloak. It stops the immune system from recognizing them as enemies. So if the police can't see the criminals, they can't arrest them. It's a really clever evasion tactic.
And then there's the one that I think really scares people the most, the one that makes cancer seem so pervasive, its ability to spread.
Yes, that's a third one, and arguably the most dangerous superpower.
Yeah.
Metastasis. The ability to spread. See, normal cells are usually stuck together, they form tissues, they have connections, but cancer cells can acquire mutations that break those connections, break those bonds. This lets them escape from where they started, get into the bloodstream or the lymphatic system, and travel to distant parts of the body, where they can set up shop and form new tumors, new colonies. Metastasis is, unfortunately, a primary reason cancer becomes so incredibly difficult to treat. It turns what might have been a local problem into a body-wide one. You might successfully treat a tumor in the liver, for example, only for another one to pop up in the brain weeks later, all originating from that first highly mobile cell.
So it's not just that cancer is 200 different diseases, but even inside one person, a single tumor can be this, like wildly diverse, constantly changing, moving target. That sounds almost impossibly complex.
It is. It absolutely is. And this brings us right back to that concept of heterogeneity, variety. Every single tumor is distinct. Even if two people have, let's say, lung cancer, their tumor's genetic makeup, the specific superpowers their cells have acquired, can be totally different. So what works wonders for patient A might do absolutely nothing for patient B.
Right.
And it gets even more complex. There's intratumor heterogeneity. That means even within one tumor in one person, the cells aren't all the same. It's like an enemy army where different soldiers have different skills. Some are resistant to a particular drug, others multiply faster, some are better at hiding from the immune system. If you manage to wipe out one group, another group with different strengths might survive, adapt, and cause the tumor to grow back. The big so what here, the really crucial point, is that this extreme dynamic complexity is exactly why there's no single universal cure. It's why we desperately need highly personalized strategies tailored to each specific case.
Okay, so given all that complexity, that Hydra-like nature you described, how do we actually fight cancer effectively? I mean, it sounds daunting, but we have made huge progress, haven't we? It's not all bad news.
No, absolutely not. We've made enormous strides, significant progress. The ultimate goal, despite all the challenges, is still the same. You want to eliminate every single tumor cell that has the ability to reproduce. Every last one. Now, traditionally, one of the main strategies has been to just directly attack the DNA of cancer cells, trying to damage them so badly they die. Radiotherapy, for instance, uses high-energy rays, like gamma rays or proton beams, to literally blast the DNA. And chemotherapy often uses drugs, like doxorubicin is a common one. It works by getting inside the cell and physically blocking the DNA copying process, causing massive damage. The idea with these is basically to overwhelm the cancer cell's repair mechanisms and force it into dying.
But those classic treatments, chemo and radiation, they come with some pretty serious downsides, right? That's where all the tough side effects come in. The nausea, hair loss.
That is the major drawback, the real dilemma. These treatments, they're often not very specific. They tend to harm any cells that divide rapidly. And yes, cancer cells divide rapidly, but so do lots of healthy cells in our bodies. Think about the cells lining your gut, or your hair follicles, or the cells that make your blood. They divide quickly, too. So the treatments damage those healthy cells as well, leading to those difficult side effects. Nausea, hair loss, a weakened immune system, anemia. Sometimes the side effects get so bad that doctors actually have to pause or stop the treatment. And that's incredibly risky, of course, because it gives the tumor a chance to recover, keep growing, and potentially develop even more resistance.
So the future then, it's clearly about being smarter, more targeted,
Ugh.
less
Have to
collateral damage.
Exactly. That's where the cutting edge of research is really focused now. Finding ways to attack the cancer cells specifically without causing so much harm to the rest of the body. One really exciting area is nanomedicine. The idea here is to package chemotherapy drugs inside tiny nanoparticles.
Nanoparticles,
Yeah.
like microscopic delivery trucks.
Kind of, yeah. These nanoparticles are designed to deliver the drug payload directly to the tumor site. This means you can get a higher concentration of the drug where it's needed, making it more effective, while reducing the exposure to healthy tissues, which cuts down on side effects. Doxil, for example, is basically doxorubicin wrapped in a nanoparticle. It's a much more targeted version of the older drug.
That sounds promising.
And then there's immunotherapy, which is truly revolutionary. It's a completely different approach. Immunotherapy doesn't directly attack the tumor itself. Instead, it harnesses the power of the patient's own immune system. It basically trains or boosts the immune cells to recognize and attack the cancer. Things like CRT cell therapies, for instance, they actually take a patient's immune cells out, genetically reprogram them in the lab to specifically target their cancer, and then put them back into the body. And we're seeing incredible results, even complete cures with these therapies, especially in certain types of blood cancers. It's a really exciting frontier.
You know, we've covered what cancer is, how it behaves, how we treat it, but there's another angle here. Often the biggest win happens before any treatment even starts, doesn't it? There's kind of an unsung hero in this whole story.
Ah, you must be talking about early diagnosis. And you're absolutely right. Catching cancer early is, in so many cases, the single most powerful weapon we have against it.
Why is that? What makes early detection so critical?
Well, think about it. The earlier you catch it, the less time it's had to grow, to accumulate those dangerous mutations we talked about, those superpowers. There's much less chance it has spread metastasized to other parts of the body. This means the treatments required are often much less aggressive, they tend to be more effective, and the chances of a complete cure are significantly higher. That's precisely why screening programs are so vital. Things like mammograms for breast cancer, they can reduce mortality by up to 30%, or screening for colon cancer. If you catch it early, the cure rate can be as high as 90%. 90%. Early detection makes a massive difference.
And I hear there's something new on the horizon that could totally change the game for early diagnosis, something involving AI.
Indeed. Artificial intelligence has the potential to be a complete game changer in early detection. There's software being developed right now that can analyze medical images like scans or biopsies with incredible precision. Some systems are even showing promise in detecting subtle cellular changes, potentially years, maybe even up to 5 years, before cancer would normally become detectable as a tumor.
5 years. Wow.
Imagine that. It could lead to a really profound shift towards anticipatory care, catching things incredibly early, maybe even preventing cancer from fully developing in the first place, rather than just reacting once it's established. It could be huge.
So after exploring all of this, the complexity, the superpowers, the treatments, the importance of catching it early, let's circle back to that big question. Does the idea of a single, universal cure for cancer still hold water? Or is that just wishful thinking?
Honestly, based on everything we know, it's probably not realistic. Not probable. Like we've discussed, cancer isn't one disease, right? It's over 200. Each tumor behaves uniquely because of its specific set of mutations. And it's not static, it evolves, even within one person over time. What works for lung cancer might not touch pancreatic cancer. What works for patient A's lung cancer might not work for patient B's. Given that incredible dynamic complexity, hoping for one single magic bullet that cures everything, it just doesn't seem likely. What we really need, and what science is actively pursuing, is a toolkit of personalized, adaptable strategies for each specific type and stage of cancer, for each individual patient.
Which leads us right into that persistent myth, that conspiracy theory you sometimes hear. Big Pharma has the cure for cancer. They're just hiding it to make money from treatments. You hear that a lot online.
Yes, you do. And while I understand where the sentiment might come from, yes, pharmaceutical companies are businesses, profit is part of the equation. The logic of that conspiracy just doesn't hold up. Think about it realistically. If a company actually discovered a universal cure for all cancers, all of them, can you imagine the impact? Cancer affects millions worldwide. It's one of the biggest health crises, one of the biggest markets. A universal cure wouldn't just be hidden. It would be the single greatest medical and commercial breakthrough in human history. The company holding that patent wouldn't need to hide it. They would make unimaginable amounts of money. They'd be heroes. They'd dominate the global healthcare market. The problem isn't some secret cure being hidden away. The problem is that the very concept of a single universal cure just doesn't align with the fundamental biological reality of what cancer actually is. Hundreds of complex, evolving diseases.
Okay, so the real story isn't about a hidden cure that doesn't exist. It's actually about, well, real, tangible progress happening right now.
Exactly. That's the crucial message to take away. We've made incredible progress. We have therapies now, like nanomedicine and especially immunotherapy, that are becoming more and more precise, more targeted. These breakthroughs mean we can now cure many types of cancer that were once death sentences. We can control many others for years, even decades, turning them into manageable chronic conditions. We're improving the quality of life for millions of patients. It's a story of relentless scientific effort, personalization, and steady, significant advancement.
And while all that amazing science continues pushing forward, there's something really important that you, listening right now, can do. It really comes down to personal vigilance. You have to listen to your own body.
That's absolutely right. Pay attention. Notice things. Is there a new lump somewhere? Has a mole changed its shape or color? Are you feeling unusually tired, like deep fatigue you can't explain and it's just not going away? Detecting something abnormal early, bringing it to a doctor's attention, that simple act can genuinely make all the difference in the world. And of course, we can't forget prevention. It's always better to stop cancer before it even starts, if possible. Living a healthy lifestyle that means no tobacco, eating a balanced diet, getting regular physical activity, protecting your skin from the sun, and keeping up with recommended medical checkups and screenings, all of this significantly stacks the odds in your favor. When you're talking about something like cancer, every single advantage counts.
So the advice is clear. Take care of yourself, really listen to your body, and if something feels off, if something worries you, don't wait. Go see a doctor. And maybe here's a final thought for you to carry away from our deep dive today. Really understanding cancer not as one single monstrous thing, but as this incredibly diverse collection of evolving enemies. That understanding fundamentally changes how we need to approach fighting it. Perhaps the real cure isn't going to be one single dramatic breakthrough after all. Maybe it lies in our collective, personalized, and absolute relentless pursuit of knowledge, treatment, and vigilance.